So stone wool is a very environmentally stable product, very sustainable. It's a natural renewable resource. It also does not off-gas into the environment. There are no blowing agents that we use in the product itself. In the production process, it's zero waste to landfill. So any of the scraps that do kind of come off of the line actually kind of get melted back down into briquettes, and then we completely reuse it. That being said, also end of life cycle, if you are nearby a plant, you could actually recycle, bring back all the old product or scraps that you have from the job site, and actually we'll turn that back into more material. One thing, and I know it's been kind of turning a little higher and higher, is the carbon or embodied energy or carbon footprint of our material. And it does take a lot more heat than other materials to make. But one thing to note is, first of all, the longevity of stone wool just being installed in your walls. We've actually just pulled out samples of rock wool in Denmark, where we originally were founded, from 65 years ago, still showing the same exact R value as the day that it was installed. And stone wool insulation, after a 50-year time span, will save 128 times the amount of energy used to produce the product. We also are a recycled product, 16 to 40%. We could even increase that depending on the project as well. And of course, we're all Green Guard Gold certified as well, and that really helps with indoor air quality. So currently we are the world leader of stone wool insulation. In North America right now, we have 3 functioning factories, one in Toronto. We began that one in 1988. Then 1999, we began one in Grand Forks, British Columbia, Canada. And then in 2014, we opened up our first US-based plant down in Marshall County, Mississippi. And we're actually currently working on a plant in Ranson, West Virginia. And then that's in the panhandle of West Virginia. We also have 16 stone wool factories in the European market, and that's really where we were first founded. And then even in Russia, we have 4 stone wool factories. And in Asia, we also have 5 stone wool factories. So the big thing with, even when you start looking at carbon footprints is we want to have factories close to the job site. So we always try to build the factories near where the usage is going to be the greatest to really reduce our environmental impact on all the transport. So with Rockwool, we really offer total home solutions. And this, again, new construction, but I think also for, when you start looking at remodeling and when you start talking about vapor open products, this is where it's very important. So, for a remodel, let's say, you want to go with continuous insulation on a home, and let's say you don't know if you already have a vapor barrier on the interior. So typically if you're in climate zones 5, 6, 7, or even 8, you might actually find that you have an interior vapor barrier, but you don't know that. So if you start putting these vapor barriers or, foam insulation more than typically about 2 inches, you essentially could have a trap system. And with that, you're essentially possibly going to increase the moisture inside of your wall cavity. So by putting a vapor open product on the exterior of a remodel, now it's still able to dry one way or the other. So some of the other applications that we do are approved now. It's below grade, so you could actually put us underneath a slab. And then also below grade, so you could put us up against a foundation. You would still need your waterproofing. And then you could also use this as continuous insulation, and then regular bat insulation, so a replacement to like a fiberglass bat, and then also fire and sound applications. And a lot of the times you'll find with stone wool, you could reduce the amount of drywall that you're actually using in that application to get to a 1-hour fire rating. And then also party wall systems. So, typically you need a 1-hour fire rating there. So again, reducing the amount of drywall and getting STC ratings that are close, anywhere from 45 to up to 60 even. So there are really many beneficial properties of stone wool when using throughout the building. Today we're going to go through 6 properties that I feel are the most beneficial to creating high performance systems and assemblies. The first property we will discuss is the fire resistance of stone wool, and this is the property that I think a lot of people already kind of know about. And really, why is this important? We have these major tragedies that occur. You have loss of life situations, and a lot of them are actually during construction that you'll find when you have exposed flammable products. So this one was the Grenfell Tower back in 2017, and you could see just the time lapse of how quickly that fire spread. And this also really helped jolt the industry and really explain why we need NFPA 285, which I'll go in more detail in a little bit. But really, when you look at stone wool versus other insulation products that are currently on the market, you look at the ASTM E84 testing, and what that really is, ASTM 84, it's a 25-foot long tunnel, and then they also have a spectrophotometer which measures the density of the smoke. So in the 25-foot long tunnel, they have 25 feet worth of that insulation material. So they start a fire at one end, and they see how many feet it goes to the end of the tunnel. So you could see with stone wool, the flame spread was 0, meaning that it spread 0 feet. And the smoke development was 0 as well, so there was no smoke development either. Then when you start looking at some of these other materials like fiberglass, the flame spread was less than 25 feet, and the smoke development was less than 50 parts per million, I believe. Then you have cellulose, which again, less than 25 feet. So it didn't really get down to the full 25 feet after a 15-minute burn cycle. And then smoke development also is less than 50. When you start looking at a lot of these foams and plastics that aren't treated with a fire-resistant chemical, you could have flame spread that maxes out the entire test at 25, and even smoke development, which is pretty much 450, is going to be the highest for that test. And then in a controlled burn, you could look at this diagram on the right. In a controlled burn, it actually takes 6 hours for stone wool to get to our melting temperature, and that melting temperature is 2,150 degrees. Whereas fiberglass, depending on the density, it could be anywhere from 900 to 1,200 degrees Fahrenheit. And a lot of the foams and plastics are going to melt between 250 and 400 degrees. So NFPA 285, and this is actually a full wall assembly. So a lot of products will say, by mistake that they're an approved NFPA 285 product, but really it's the entire assembly. So when you start using combustible components that are part of this assembly, this is what that test is for. And really what it simulates is when you have, an apartment complex and you have a fire in one apartment, you don't want the fire to actually go out the window and crawl up the exterior of that building. So by using a product like stone wool, you actually don't need to do a lot of the testing that you would need to if you have combustible products. And then this is a test for residential construction. This kind of simulates like a grill fire. And the bottom is stone wool, and you can see it's time lapsed by quite a bit. So you can see we're already at about 4 minutes. You'll notice that the vinyl siding starts melting, and we have stone wool underneath this wall, and we have XPS on the exterior of this wall. We're at 45 seconds. And then the right side of the video is actually just a regular attic. And when you start looking at some of these WUI areas or the wildlife urban interface areas in like California, and I believe even in Utah and Texas, they have some of these wildfire areas that now they're trying to do more non-vented attics just to prevent embers from going up into these attics. Because now what matters is what's in your attic could possibly be a combustible product, and then once these hot embers get into your attic, then your fire begins in the attic of your home. So you can see we're at about 2 minutes and 15 seconds on the XPS. You can see the smoke. So at this point, that's telling you that the foam itself is actually burning. Vinyl siding will melt. It won't really produce too much smoke, but it's going to melt. And you can see 2 minutes, 45 seconds. Now you're starting to get a little bit of that smoke coming out of the attic. And now you're getting flash over at 3 minutes. Whereas stone wool, we go all the way up to the 30-minute mark on this test, and still it's just a contained to basically the grill. So now we'll take a look at another property of stone wool insulation, its sound absorbency. And everything is louder today, or so it seems. We are also designing open concept homes, which sound can go right through, from the kitchen to the living room. Appliances are louder. Video games, televisions, phones, all increase the noise level of the home. And that also increases stress level and reduces comfort. So density and mass are the best for blocking sound, and that's really where the higher density of stone wool insulation comes in. But not only is it just the density and mass, but it's also how it's fitting in that wall cavity. So stone wool really does shape with a simple serrated knife, and it's very easy to mold around obstacles. Similar to thermal insulation, if you leave large gaps or if gaps appear over time, all the sound or thermal value is going to escape through those openings. And then the next property is water repellency. And this one, I feel like a lot of people that are familiar with stone wool still aren't, don't know about this attribute of the material itself. So it is very common to think that stone wool is fibrous insulation, that it has the same properties as fiberglass. Some think that because fiberglass absorbs moisture, stone wool must absorb moisture as well, but this is actually not the case. Every fiber of stone wool from the production process is actually coated with a moisture-resistant oil, making it hydrophobic. Therefore, if water is poured on the product, it'll shed right off. It is not affected by wet or dry cycles, meaning that the product can be left exposed to moisture and it will not absorb it. You could actually see this on the lower image comparing a bat of fiberglass insulation and mineral wool insulation on the other. And because of the hydrophobic nature of stone wool products, water does not get absorbed or held by the insulation, but is allowed to run off and drain out. And that's a big part of the whole vapor open airtight concept too. So this was a test that we did. We pretty much just took a sample of our product, held it underwater for 30 minutes. When we pulled it out, in 1 minute, it still only showed 3.69% volume in that. And then 15 minutes, 60 minutes, you could see the percentage. And then in 12 hours, it was completely dried out. So what does this really mean in an application? I mean, I always bring up basements. If you do have like a pipe burst or a hot water heater that goes, what happens a lot of the times is you might only get 5 or 6 inches of water in your basement, but if you have a fibrous insulation in the walls, it could possibly, wick up through the wall and damage more. With us, what we recommend doing is just really cutting away the drywall that got damaged, then letting our product air out. I usually say 2 to 3 days, and then just patch up the drywall. You don't need to worry about mold or mildew either. And then a question that is often asked, especially when we start talking about below grade applications, when we are in contact with soil. Now, one thing about the application, when you're going below grade, I still recommend using some sort of a dimple mat to keep a lot of the water or the soil away from the stone wool insulation. But this is just a question that gets asked of us quite a bit. So really, what happens to the thermal performance of stone wool in the presence of moisture? And we had this test done, and it's a institute that's organization located in Germany and Boston that performs roofing analysis as well. But what they did, they actually tested it, and they just basically added water until it got up to 3.1 pounds per cubic foot. We noticed that the water or the R value actually remains pretty stable even when it's saturated. And it's also going to dry out very quickly. Typically, when you're going below grade, you're putting the stone wool in a vertical manner also. So it's going to increase the drying potential that much more. And also you have a French drain at the bottom of that assembly, so it's able to dry right out into the French drain. And then some other added benefits, and these are the less known benefits that we really go in with. So really, this is more of a temperature test. They test R value at 75 degrees Fahrenheit. I don't know about you. I open up my windows when it's 75 degrees Fahrenheit, but that's just industry standard. That's what we're asked to, test all of our R values at. And if you look at the red line, that's our regular cavity wall insulation, so our bat product. And at 75 degrees, we're at 4.3 per inch. And if you actually, as it gets colder, it gets up to about 4.8 per inch. So you're actually increasing R value as it gets colder. And this is the same holds true for our board products as well. Versus like a polyiso, and they're the biggest culprit with this. They could reduce up to 20% R value as it gets colder. So at 75 degrees Fahrenheit, they're right around a 5.7 per inch, and at 25 degrees Fahrenheit, they're around a 4.8 per inch. And then off-gassing, and really, this is kind of a concept about, it's both for indoor air quality, but it's also going to reduce an R value. So a lot of the foams, they actually use blowing agents. And if you figure like a ping pong ball and what happens over time, those ping pong balls degrade and the blowing agent will actually be removed from that bubble. And then air just fills it in, so it reduces R value. And these are as per manufacturer. On every one of their boards, they actually show this. But so like a polyiso board starts at an R 5.6, and anywhere from your 2 to 20, just due to off-gassing, it's actually going to reduce in R value by 20%, whereas XPS is 10%. If you look at the products that aren't affected, it's really stone wool, you have EPS, you have cellulose, and you have fiberglass. And then indoor air quality. And as I mentioned before, it's a huge talking point nowadays. We're spending up to 90% of our time indoors. So the air we are breathing while in our homes is very important. We filter our air, we filter our water or, buy purified or spring water. So why are we okay with poor indoor air quality? And really, you need to start looking at all the materials that we're putting in our homes. Down to the carpet and even the furniture. There's more and more off-gassing and other chemicals that we're really bringing into our homes. And now that we're making all these more airtight houses, we're breathing all those chemicals in. So Rockwell is Green Guard Gold certified, which is a huge deal. We will not degrade the air quality one bit. And due to the vapor open and water repellent properties, there's less chance of mold and mildew in your wall, which in turn will degrade your indoor air quality as well. And then termite resistance, and this was a test that we did not too long ago, so this is a fairly new test. We basically did this out in Hawaii with 400 Firmicin termites, which are the nastiest termites that you could really find. And if you look at that weight loss column, and that's the one that really I like to look at. So if you look at like untreated lumber, you're looking at 51% weight loss, and I think everybody on here knows that and understands that. But then treated lumber is about 4.85% weight loss, and stone wool is 4 times less than pressure treated lumber. So when you start talking below grade applications, you don't have to worry about these termites getting into stone wool and using your exterior insulation or your continuous insulation as basically a insect superhighway up to the top of your house. And then you could look, I have some pictures of foam products too. And these were, a lot of the times, they're finding a lot of this issue in more of the climate zones, which you could see on the map, where those are. But because foam is very easy to tunnel through and it's dark, the termites really love going through it. And then exposure and durability. And this, I think, is a really big one. Again, it's rock. So rocks don't sunburn. we do recommend covering it over within 6 months. But for this instance, this was a hospital project that we did up in Montreal. And they basically built the main structure. And then they were, instead of recladding everything, they were going to be adding an addition on 2 years later. So they had to leave it exposed for 2 years. We monitored the site and found that there was no loss in R value and no product degradation either. And then dimensional stability. Really, I say, Rockies don't shrink in the winter months. So same thing, rocks don't shrink. We're very dimensionally stable. And this was a roof assembly using polyiso, and you could see all the shrinkage and all the thermal bridging as well from just the fasteners.
Thanks for watching. Please continue to watch the next part of the session to complete the course and get your continuing education credits. Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.